After the cathode plate heats up, electrons accelerate toward the anode. Some pass through a minuscule hole on the anode plate, producing an electron beam. As we adjust the voltage from the power supply, we can see the electron beam lengthening and shortening. Here we are exploring the effect that a magnetic field has on the electron beam when the voltage is high enough that the beam has reached the interior of the glass bulb. As we bring one end of a strong bar magnet up close to the electron beam, we can see the beam of light bending, eventually forming an almost complete circle that follows the curve of the glass bulb. Moving the magnet around creates a light show reminiscent of the aurora. Here, the blue light that we see is a result of the electrons interacting with trace amounts of helium gas. However, in the night sky, we are more likely to see yellows, greens, and even reds due to the presence of oxygen and nitrogen in the atmosphere. In comparing the effects of a strong magnet versus a weak magnet on the electron beam, we can see a dramatic difference. The weaker magnet barely caused the beam to budge, while the stronger magnet resulted in arcing and swirling behavior.
I never ever saw the northern lights. I never really heard of cluster flies. Never ever saw the stars so bright. In the farmhouse things will be alright. I never ever saw the northern lights. I never really heard of cluster flies.